Coral reef ecosystem is very sensitive to climate change because it can only tolerate a small variation on the temperature. And if this temperature increase beyond their limit, it kills corals.
So we're faced with this reality, and it's devastating. But then you jump in the water and you see in some far corner of the coral reef where maybe you hadn't looked before, there's life. There's a whole community of corals of all shapes and sizes and species that are still alive, that survived the heat waves when their neighbors didn't. They're thriving. All the fish are congregating there. It's like a jewel under the sea.
Just in the last couple of years, we've developed a technology to identify climate-resilient reefs. These are truly the reefs that our children and our grandchildren will be snorkeling over, naturally positioned to survive ocean warming.
And so those different genotypes of corals that could be resistant to warmer temperatures or more acidic conditions, they already exist. What we're working on is A, can we find them? And B, can we continue to propagate those to help bolster a reef's resilience to those increased temperatures or to that increased acidity?
Here are the areas of your coral reef ecosystem that, if incorporated into marine protected areas, if they are protected from the threats of overfishing, pollution, dynamiting, they have the best chance not only of surviving future climate change, increased warming, next heat waves, but they're also going to reseed and regrow the reef.
We're realizing that there are some things we can do by protecting those resilient areas, so that allows for global community to study and understand why these corals are surviving in this environment, and are there opportunities for these corals to also help address these global challenges that we're all facing.
The Super Reefs project really is built around these three institutions. Woods Hole, who sort of began this concept and started leading it, Stanford, TNC, and we'd all been working in this area already, but in different zones. And so it was actually Ann Cohen who brought us together and said, look, we have these different elements, they really work well. And those elements are to predict where the warm water reefs are and where the corals might be heat resistant, and then prove that. That's what we do. And then use that information to protect them. And that's the TNC link. And that's what's so exciting about it.
And so if we can identify these corals and then use these corals as a seed in these restoration efforts, then they'll be able to do better in the next bleaching event, which we know that is going to happen, and that we're going to have more frequent and more intense bleaching event.
So what's really exciting about this project is that a decade ago, there's no way we could do it. We didn't have the science, we didn't have the modeling capabilities, and we certainly didn't have these global partnerships of bringing all of these different areas of expertise together.
So as sea surface temperatures rise, these corals are not just surviving, but thriving. We have corals that are experiencing ocean acidification levels that are expected at the end of the century. And again, they're thriving, not just surviving. That gives me great hope.
Think about having the opportunity of saving an entire ocean ecosystem. We do. We have that opportunity. We have it now.